If I put this picture in front of you, would you say that it's a lion or a tiger? For us humans, that seems obvious. We instantly recognize certain features, like the orange body and the black stripes. But for a computer, it's not so simple. A computer doesn't see images like we do. It sees raw pixel data. Each image is just a set of numbers telling the computer which color to show and where. So how does a computer know that this is a tiger? It learns, just like we do, by recognizing patterns. Using special algorithms, a computer can scan thousands of tiger images, gradually learning what features tigers tend to have. It becomes better and better at spotting those features in new images. Eventually, it can take a brand new photo and say, with high confidence, this is a tiger. This process is called machine learning. When a computer learns to make predictions from data, it creates something known as a model, which takes an input like an image and gives an output, like how confident it is that the image belongs to a certain category. In this example, we looked at classification, where the goal is to sort data into categories, like tiger or lion. But machine learning isn't limited to categories. It can also predict numbers. This is called regression. Take housing prices, for instance. If we give a machine data on houses, like square footage and price, it can learn the mathematical relationship between those numbers. In this case, a linear regression is being performed on data points to calculate a linear function. Now, when you input a new square footage, the linear function can estimate the price of the house. One of the most challenging parts of building a machine learning model is collecting and preparing the training data. In many cases, the raw data isn't in the format you need. That's where data pre-processing comes in. It involves cleaning, organizing, and transforming the data so it's ready for the model to learn from. Machine learning algorithms can generally be divided into two categories: supervised and unsupervised learning. Supervised learning uses training data that's labeled with both inputs and expected outputs. The model learns to map inputs to outputs and make predictions. For example, both the tiger versus lion image classifier and the house price predictor are supervised learning models. They're trained to predict an output given a new input. In contrast, unsupervised learning works with data that has no labels. The goal here isn't to predict specific outcomes, but to uncover patterns or structure within the data. A common example is clustering, where the algorithm groups data points based on shared characteristics, like grouping customers by similar buying habits. When training a machine learning model, we typically split the data into two parts: training data and testing data. The model learns patterns from the training data, and then is tested on the testing data to see how well it performs on new, unseen examples. This split helps prevent something known as overfitting, a situation where the model becomes too good at memorizing the training data, but fails to generalize to new inputs. Think of it like studying for a final exam. If you only memorize answers from last year's papers, without actually understanding the material, you might do fine on those exact questions, but you'll struggle with anything new. In other words, you haven't truly learned. Now, imagine instead you split those old exams into two sets. You study using the first set, the training data, to understand how to approach the questions. Then you quiz yourself using the second set, the testing data, to check if you really understand the concepts. That way, you're learning how to solve problems, not just memorizing answers. It's the same with machine learning. By training on one portion of the data and testing on another, the model learns more effectively, avoids overfitting, and becomes better at making accurate predictions in the future. Building machine learning models typically involves programming, and the most commonly used language in this field is Python. Python is popular because it's easy to read and has a wide range of libraries specifically designed for data science and machine learning. For example, Pandas is used to load, explore, and clean raw data, making it easier to work with structured information. NumPy helps perform efficient mathematical and logical operations on large arrays and matrices. When it comes to actually training the model, libraries like scikit-learn, TensorFlow, and PyTorch are commonly used. Scikit-learn is ideal for classical machine learning methods like decision trees and support vector machines, while TensorFlow and PyTorch are powerful tools for building deep learning models such as neural networks. To visualize data and model performance, Python also offers libraries like matplotlib and seaborn, which allow you to create graphs, charts, and other visuals to better understand patterns and results. Together, these tools form the backbone of most machine learning workflows in Python. This video is just a quick overview of some of the things machine learning can do and a basic idea of how they work. There's so much more to explore, so stay tuned as we dive deeper into specific topics on this channel.